Welcome back. Today we're going to be talking about volume and surface area of square-based pyramids and cones. So let's go ahead and get started with that by taking a look at some vocabulary. So we've got three vocabulary terms that we need to know. First, volume measures the capacity of an object, so that's how much an object is going to hold. Surface area measures the total area an object occupies, so that's all the faces, including the top and the bottom. And we can use formulas to calculate the volume and surface area. So now let's go try that with example A. So here in example A, it says Hasbro is attempting to package the new Transformer figure. How much space is inside the box? So since it's talking about the amount inside the box, we know that they were talking about volume. We can take a look at our picture here and see that we've got a square-based pyramid. So we're going to go on over to our formula sheet. We're going to locate our volume formula for a square-based pyramid. That's going to give you V equals 1/3 times big B times H. So big B, we haven't seen that before with capital letter B. In this case, big B, and anytime that we see it, big letter B is going to stand for B is going to equal the area of the base. So we need to find the area of the base, multiply it times 1/3, and multiply it times the height. So we've got to start by figuring out what the area of the base is. So our area of base, since our base is a rectangle or a circle, or not a circle, a rectangle or a square here, we know that we're going to be multiplying length times width. So in this case, our length is width, and our width is 6. So in order to find big B, we're going to be doing length times width, and that's going to be 6 times 6, and 6 times 6 is 36, so that gives us the area of big B. So now we need to plug the other parts into our formula. So we know that we've got 1/3, we've got 36 as our big B, and then our height, as we can see from our picture, is 10. So then we're going to just multiply all three of those together, 1/3 times 36 times 10, and we're going to get the volume equals 120 centimeters cubed. Notice that when we're talking about volume, we have cubed because we're talking about three different dimensions. We're talking about length, width, and height. Now let's take a look at example B. So here in example B, it says Hasbro is now attempting to wrap their new package for their Transformer figure. How much paper will they need? So we're talking about covering the entire package as they go to ship it out. So we're going to be talking about the surface area in this case, and we know that because we're talking about the outsides of the shape. So we're going to go over to our formula sheet. We're going to find our surface area formula for our square-based pyramid here. And our surface area is going to be 1/2 times L, standing for the slant length, times P, standing for the perimeter, plus big B, which as we talked about in the last problem, is going to be the area of the base. So before we start plugging things into our formula, we need two things that we don't have from our picture. We need to calculate our perimeter of the base, and big B, the area of the base. So let's start with our perimeter. So we're going to bring down our perimeter here. And since our perimeter of our base here is a square, we know that all the sides are going to be the same. So we're going to add up the four sides of our base, so 6 plus 6 plus 6 plus 6, so our perimeter is going to be 6 plus 6 plus 6 plus 6, and then we add those all up, we should get 24. So our perimeter is going to be 24. Now we need to find the area of the base, and luckily we did that in our last problem, and we've got the same shape here, so our area of the base is going to remain the same, but we know our base is a rectangle or a square, so length times width is going to be our formula. We know that 6 times 6 are the two sides, and 6 times 6 is going to be 36. So now that we have both the perimeter and the area of base, we can type in the information that we have in our formula. So we know 1/2 is going to be 1/2. Our slant length they gave us at the top of the problem says 10.44, so we're going to plug that in. We know that our perimeter is 24, so we'll plug that in. And we'll plug in our big B, it's going to be 36. Now, I could type this straight in the Desmos and get my correct answer, or I could do 1/2 times 10.44 times 24 and then add 36, whichever one I wanted to do. But either way that I do that, I should get a surface area of 161.28 centimeters squared. And again, since we're talking about area, even though it's surface area, it's squared. The only time that we use cubed is when we're talking about volume. Now let's take a look at example C. So here in example C, Emily is making this container out of plastic. How much plastic is needed to construct this container? So again, we're talking about the outside of our shape, so we know that we're going to be needing surface area. So we're going to go over to our formula sheet, look for the surface area of a cone, since that's the picture of the shape that we have here. So our surface area of cone formula is going to be pi r squared plus pi times the radius times the slant length. So we need to locate those items in our shape here so that we can build our formula. So pi, we know, is going to be 3.14, but our radius we do not have. They've given us the diameter, and that's going to be 10, so we need half of that for our radius, so in this case half of 10 is going to be 5. So we know that in this case our radius is going to equal 5. Then we also need to locate our slant length. So we have two choices, 12 or 13. Well, 12 goes straight up and down, so in this case 12 is going to be our height. So 13, given that it is on a slant, is our slant length. So we know 13 is what we're looking for our formula. We don't need 12 in this case. So let's go ahead and type in the pieces that we need. So we know we've got surface area is going to be 3.14. That's what we're going to be using for pi here in the state of Virginia. We've got 5 squared as our radius. We just found that. Plus 3.14 times 5 for our radius times 13 for our slant length. Now again, I could type that straight into Desmos if I'd liked, or I could do 3.14 times 5 squared, set that number aside, then 3.14 times 5 times 13, and set that number aside, and then add them together, or type them straight into Desmos. Either way, I'm going to get a surface area of 282.6 centimeters squared, because again, we're talking about surface area. Now let's take a look at the next example. So here we are at example D, and it says Erin is making snow cones. She needs to fill this paper cone with ice. How much ice can the cone hold? So since we're talking about the inside of the cone and how much it can hold, we know that we're talking about volume. So we're going to go over to our formula sheet, grab our volume formula for a cone. So V equals 1/3 times pi times r squared times h. So again, we've got to identify some things in our formula before we plug them in. So if we go ahead and grab our formula here, or our picture here, we can see that the radius is already labeled for us. We know that that's going to be 8 because it goes halfway here. And then we need to identify our height. So again, we have two choices, 15 or 17. We can see that 15 is going straight up and down, so we know that is going to be our height, whereas 17 is going to be on the side here, so we know that's our slant length. Alright, so let's plug in the pieces that we need. So we need to plug in pi, 3.14. Our radius is going to be 8 squared, so we're going to go ahead and plug that in as well. And then we're going to plug in our height, which we just said was going to be 15. So then we're going to multiply that straight into Desmos, 1/3 times 3.14 times 8 squared times 15. And if we do that, we should get a volume of 1004.8 centimeters cubed. Again, we're talking about volume now, so we have to have our answer as cubed. Now let's go ahead and take a look at the next example. So here in example E, things get kicked up a little bit of a notch. So it says the volume of a square base pyramid is 588 cubic inches. The height of this pyramid is 9 inches. What is the area of the base? So in all the other examples we've had so far, we've had to identify either the volume or the surface area. We were given the other parts of the formula. In this case, that's not what's happening. We have to find pieces from the missing formula when we've been given the volume in this case. So again, we're talking about a square base pyramid, so that identifies to be the formula that we need since we're talking about what is the volume. I'm going to go ahead and grab my volume formula for a square base pyramid. So my volume formula is going to be 1/3 times big B, as we talked about area of the base, and times the height. So in this case, I've got to plug in the pieces that I already know, and then we're going to go ahead and solve our old friend, an equation. So I know that 588 is my volume. I know that 1/3 is going to be 1/3. Big B I don't know, so I'll leave that as my variable. And then times 9, because that's the height of my pyramid, as they told us here in the problem. So I've identified the important parts, and I've plugged them in. So now I'm going to have to draw a wall, and we're going to start solving our equation the way that we usually do. So I'm going to have to multiply 1/3 times big B times 9. 1/3 times 9 is going to give me 3. 3 times big B is just going to be 3B, or 3 big B in this case. Bring down my 588 because I didn't do anything with that. Now I've got a one-step equation, so I'm going to divide both sides by 3. And if I divide both sides by 3, these are going to cancel, leaving me with just B on this side. And 588 divided by 3 is 196. So in this case, it's going to be 196, and we're going to say it's going to be inches squared because we're talking about the area of the base. And since we're talking about area, we know that that needs to be squared. So 196 inches squared is big B, and I am done. Now let's go ahead and take a look at the last example. So here in example F, it says the surface area of the cone is 432 meters squared. The diameter of the cone is 16 meters. What is the slant height? So again, we're missing some pieces of our information, or missing a piece of our formula, but we've been given the surface area. So they told us that the surface area in this case is going to be 432. They told us that the diameter is 16, so that's going to be interesting because we know in our formula we're going to need radius, and we're trying to find our slant height. So first we're going to go over and grab our surface area of a cone formula. So we've got surface area of a cone formula is going to be pi r squared plus pi r times L. So now we're going to put in the information that we know. So we know pi is going to be, well, we know our surface area is 432. We know that pi is 3.14. We know our radius, in this case, we don't actually know our radius because our diameter is going to be 16. So in this case, our radius is not going to be known immediately to us. We're going to have to figure it out. So since our diameter is going to be 16, we're going to need to cut that in half. So 16 divided by 2 is going to give us a radius of 8. So now that we know our radius, we can go ahead and plug that into our formula along with the other information that we know. So 432 equals 3.14 times 8 squared, as we talked about that's our radius, plus 3.14 times 8, because that's our radius, times L, because we don't know our slant length, or slant height in this case. That's the thing that we're looking for. So we're going to go ahead and draw our wall down from our equal sign. We're going to go ahead and solve our equation. So the first thing that we need to do is simplify our equation on the right-hand side. You've got to multiply to get some things together. So I'm going to do 3.14 times 8 squared. That's going to leave me with 200.96 on that side, plus 3.14 times 8 times L. I don't know what L is, but I can do 8 times 3.15 or 3.14 to get 25.12. Terrible looking 5, but there we go. Don't forget that that's an L. And then bring down my 432 because I didn't do anything with that. So now I've got a two-step equation. So the first thing I've got to do is remove my constant by subtracting 200.96 from both sides. These are going to cancel, leaving me 25.12 L on this side. 432 minus 296 is going to give me 231.04. And then I've got a one-step equation where I'm going to need to divide both sides of my equation by 25.12. These are going to cancel, leaving me with just L on this side and 231.04 divided by 25.12. As you can imagine, does not come out evenly. It comes to a fraction that we're going to round to the nearest hundredth. It's like 9.19745. We're going to round that to the nearest hundredth, so that's going to give us 9.20. And again, this is just a regular amount. It's just a slant length. So in this case, it's just going to be 9.20 meters. No squared, no cubed, just 9.2 meters is going to be our slant length or slant height. They are the same thing. That brings us to the end of this example. It also brings us to the end of this set of notes. If you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will catch you in the next one.